Welcome back, guys. So this is question 2.4 from the similar book of electric circuit by Nilsson. And the statement of this question is, if the interconnection in figure P2.4, this is the figure, is valid, find the total power developed by the voltage sources. Okay, here we have this voltage source and this voltage source as well. If the interconnection is not valid, explain why. Okay, so first of all, let me explain here that what is mean by the valid and invalid electric circuit. So in terms of the voltage sources, if we have a voltage source connected here, some other thing just like resistor or capacitor or some other element here, and another voltage source is here, and also one or two or many voltage sources are here which are also connected in parallel with them. So suppose this is VA, the value of it is VB, okay, and there are many, and let me have here VC, okay, plus minus, okay, such that VA is not equal to VB. Okay, so in this case, if you have two or more than two sources here such that the voltages they have are different from each other, so this one is basically the invalid circuit. Why? Because of the reason that in parallel circuit voltage always remains the same. Okay, here the voltages will remain the same if this is point A, B, C, D. Okay, if these are connected in parallel. And what is meant by parallel? Parallel means that both the terminals of the elements are connected in similar point. Okay, if I want to redraw it, I can redraw it in this way as well. Okay, and if there are more than these sources, these are here. Okay, so here we can see that the connection points A and B here are similar, so these are in parallel with each other. So when these are in parallel, the voltages remain same in between them. But if these are not similar one, this source or this circuit is basically the invalid circuit. Another case is that if we have a series circuit, and in this series circuit I have two or more than two current sources. Okay, so let me have here, and these current sources are not equivalent in values. If this is IA, this is IB. Okay, and if IA is not equal to IB, this one is also the invalid circuit, because here according to the circuit analysis rules, the current in a branch of a series circuit will always remains the same. Okay, but here we can see that this is not the phenomena when this condition is satisfied. Okay, so keeping these two things in our mind, let us evaluate this circuit. And here we can see that if we have this loop and this loop as well, and we want to see that what are the conditions, whether this or this is met or not. So we can see that according to this first circuit, we can see here that none of the voltage sources are in parallel with each other. These two nodes are not connected directly with these two nodes, so therefore these are not in parallel with each other. Similarly, if we see here in this loop, the current remains the same, which is this 8 ampere. But here when we come to this loop, we can see that here this current is the only constant one, but in this branch the value of it is 4 ampere, while here this is 3 ampere, while this IA is constant throughout this loop. Therefore we can see that here in this loop there are two current sources, and 4A is not equal to 3A. So therefore this circuit is just like this one, and we can see that this is invalid circuit. Okay, so I have explained the reason that why is it not a valid circuit, and I hope you have understood the reason behind the invalidity of this circuit. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.